This video we're going to look at how we differentiate expressions or equations which have fractional terms or fractions involved. So very easy. It's not really much different than the previous one. We could have left that in the first video. The number in front of the various x terms are called coefficients. So in this example, the coefficient of the x to the power 5 term is a half. The coefficient of the x squared term is minus 4 over 5, and the minus is very important. And this is the numerical coefficient, or a numerical term, or else it is the x to the power of 0 coefficient. So it's important. We'll see that much later on in mathematics as well. The same rules apply as before, so I'll just write down what our rule was. So our rule was if you had a x to the power of n, and then you differentiated it, what you would get would be n times a times x to the power of minus 1. So you multiplied by the power and you reduced the power by 1. Dead simple. So here in this example, the same idea. We're just going to just get started here. If you differentiate and you've got term by term, so really it is 5 times, I'm showing all the working out here. I wouldn't normally do this, to be honest. 5 times a half x, and that x is now to the power of 4. And over here, the 2 comes down and multiplies, so it's 2 times 4 over 5 times x to the power of just 1, and differentiate the 9, you get 0. So this is an absolute mess. Let's just tidy it up. 5 times a half is just going to be 5 over 2, and that's x to the power of 4. And 2 times that 4 over 5 is going to be 8, and it was minus 2, remember, so it's minus 8 over 5, and that's just x. And that's it done. I wouldn't change that to a mixed number. I would leave it as it is. It's actually nicer to work with the top-heavy fraction in these. Okay, next example. Here we've got 4 terms again. So if we differentiate this and see what we get, 8 is our numerical term or constant. If you differentiate constant, you get 0. Remember. So we've done this one. We're now on to the next one here. We're differentiating our x squared. So if you differentiate x squared, you're just going to get 2x to the power of 1, which we're just going to write as 2x. Then we'll bring the 3 across, or sorry, multiply by 3. So now 3 times 2 over 9, and that's now x squared. And it's now 9 times 5 over 18, and then that's x to the power of 8. Now your exam is a calculator exam, so you can, if you need to, put these in. But it's nice to address these wee things when they come up. Here you can see you've got a 3 multiplying and you have a 9 on the bottom line. So 3 will go into itself and 3 will go into the 9 3 times. So this whole bit, minus 3 upon 2 over 9, will just become minus 2 over 3. So it just tidies up nicely. Minus 2 over 3, and that's x squared. Over here, same idea. You have a 9 here and an 18. 9 goes in itself once, 9 goes into the 18 twice. So that will now become 5 over 2 x to the power of 8, and that's it. Okay, you are now ready to do exercise 6b.